able to hear me? Okay, okay, okay. All right. Okay, so let me just. Before we start, let's have a look at the Bombay course plan. Yeah. Okay, so right now we are in week 12. Okay, so you can see that this actually chapter 11 is divided into 2 weeks. Okay, week 12 and 13, right? And week 12 we're doing network design and network troubleshooting. Okay, there's two. And the second part in week 13 is network virtualization and network automation. So we are basically looking at four different aspects of modern networks, right? So we divide it to two topics per week, right? So this week we're going to look at network design and network troubleshooting. And then there will also be a network virtualization and automation in week 14, right? So let's start with network design. Okay. So I'll start with this short video demonstration of three-layer model in network design. So please bear in mind, this network design is Cisco's network design. So the way they envision how a modern enterprise network should be like. Okay, so let's have a look at this.
Hello.
You guys can hear me, right?
Uh,
You can hear me? Can. How about the video itself? Can you hear the video? The video can't hear. All right. It's okay. We can't hear the video. I'll tell you where to get and watch it. So it's under 11.1.1 video, three-layer network design. Okay. Right. Right. As I mentioned before, our topic of lecture today is part one of the chapter 11, network design. So let me start recording. Okay. So before we start, confirm you guys can hear me. Yeah. Is it clear? Okay. All right. Thank you very much. All right. Okay. Let's have a look at the topics we cover. Okay. So there are four topics here. We'll cover this lecture. The first one is hierarchical networks, right? So we're going to have a look at hierarchical networks where nowadays one of the trends is the converge and switch network. Okay, converge simply means data or different forms of data that has been uh, communicated previously via different networks now use the same network, which is a switch network, right? So we no longer have a different network for each of these, like for example, data, voice, and video. Right? Nowadays, we use the same network. So we call this trend converged networks, right? So that's under hierarchical network. And then we consider scalable networks. So scalable networks means as networks serve business purpose and as a business, enlarge, okay, scale up becomes bigger. Therefore, their needs in terms of networks, right, also scale up. So scalable networks means the network was designed, right, initially or at the beginning with consideration to enlarging the network later. Okay, so the requirements are set that okay, this network that we design now, we predict that it's going to, we have to expand it to become larger and larger, right? So in order to be able to provide this kind of network, okay, we have to include in our network design scalability. So that comes under topics of scalable networks. Right? Okay, so we've been talking about switch here from the beginning of our uh, network, network coursework ACN down to computer networks up to advanced computer networks now, right? So we'll be looking at switch. Switch is a modern way to connect hosts compared to previously with using hub. And prior to hub, we use bus network. Bus network basically uh, it's a contention-based network where you simply just connect all the cables from host to host, right? And then we centralize the connection. We have something like a hub, but our hub is working on layer one. Therefore, layer one is not able to understand um, layer two MAC address. Therefore, it's working basically in broadcast mode. So, in order to make the LAN more efficient, we introduce switch. Switch basically can do more efficient unicast messaging, whereby the switch can do um, in hardware the switching between the source and destination port is physically connecting those two ports, right? Whenever the hospital, connected to each of those ports needs to communicate, then the switch will perform the connectivity, okay, physically connecting them so that the electricity can flow, and the electricity basically carry our encoded data, right? So that's switch hardware. Then we look at router hardware. Again, router, we've been talking about router with since the FCN already. Okay, so in particular, we want to look at the offerings from Cisco in terms of switch and router. Okay, the suitability of certain models and the functionality that models basically provide. So we can look at both switch and router, right? So you can see here uh, that we can describe the type of routers that is available currently from Cisco, yeah, for small to mid-sized business network. Okay, all right. So let's look at the first topic, which is the hierarchical networks. Right. So just now I tried to show you the video. Right. So I'll still see whether we can still, because this video actually tells us about what Cisco considers as a way to design network. And there are two layers and three layers in the design. This is one of the uh, new design, which is three layer. So which is this one. I do. I think I'll share it from there. All right, so here, oops, mm, there's an echo of this. Right. So we'll talk about the three-layer network design under hierarchical networks, right? So I'm just gonna try to show you the video from this side. You let me know if you can actually hear anything.
Let's take a look at this sample network topology and the networking devices, intermediary devices, and end devices that make it up. First of all, this network has been divided into a three-layer hierarchical network design. We have the network access layer here, the distribution layer here, and the core layer here. At the network access layer, we have two workgroup switches. These are layer 2 switches capable of supporting VLANs, quality of service QoS, and power over Ethernet. We can see here how power over Ethernet is powering this access point, and power over Ethernet is also powering this IP phone. The IP phone also needs quality of service in order to maintain the quality of a voice conversation across the network. There are multiple VLANs that it supports. We have a guest network here with this blue VLAN. We have user VLANs here, the yellow VLAN and the green VLAN. Notice that this user has also attached a hub to the network so it can support extra devices. This type of activity could be considered a violation of network policy, and port security could be used to shut down this hub and these extra devices. At the distribution layer, we have two multi-layer switches. These are layer 3 switches that are not only capable of switching, but can also provide routing, including static routes and dynamic routing. These switches can also apply network policies through access lists. At the core layer, we have a multi-layer switch whose role it is to forward packets as fast as possible to the Edge 1 router. The Edge 1 router is capable of network address translation as well as being an edge firewall to the internet. In this network, the Edge 1 router connects to a cable modem, which then connects to the internet service provider and then out to the internet.
What you've seen. Okay, so I think the echo is gone. So what you've seen was the example of a hierarchical network. Okay, from the point of view of Cisco. Okay, so I'm just gonna go here. All right. It shows you a standard, basically standard design for network. Right? You see some of the um, design of the topology of the network just now. Uh, in part of your exercises for practical for packet tracer, that you've been configuring some of the uh, devices, and you can see how they connect. So the way that Cisco sees that network just now is that they divide it into three layers. Okay, access layer, and then all the way distribution, and all the way to the core layer. The core layer basically is the closest to the high bandwidth network, right? That means also at the border between your network and the ISP. Okay, right. So let's look at this need to scale the network. Right? Scaling the network simply means you're enlarging your network, right? And your network is adapting to the way your business is conducted. So, for example, your business may have just one site, yeah, one site. It's where your headquarters of your business is. So, as you scale your business, you basically not only at the one particular location, but also at remote location. So you start to open branches, right? So those branches needs to be connected back to your headquarters, and this means you need to create another network, and now that network is remote to your headquarters. So your branch may be remote to your headquarters, and the thing is, you need now to go into wide area network, right? to connect the two local area networks. Okay, so as usual, of course, um, here we talk about mission critical um, services, because usually nowadays not only this network support, provide services, support your business operation, but they are your business operation, right? So we saw this quite a lot where traditional businesses have to adapt, right? Have to adapt to do their business online, right? So when a business is doing, for example, online, yeah, like for example, e-commerce, okay, or with businesses that used to be brick and mortar, now they use some kind of app like Grab, for example, to basically offer their services and products. This means networks now become mission critical services. Mission critical simply means that if those services go down, then your business suffers. Your business cannot continue to operate, right? So when the network becomes mission critical to your business, right, then you need to provide some kind of uh, guarantee, yeah, that yes, things will happen that will bring down your network, but at the same time, what can you do to mitigate this? How can you provide a network that is will not fail spectacularly if something go down or something faulty, whatever your equipment, uh, things like that, right? So the only way is to provide redundancy. That means multiple ways for your network to survive. Okay, so some parts may be faulty and will not work, but there are other parts of your network that can take over the job, right? So this is the point of providing redundancy to your network, right? So as your business or organization compete, in the marketplace, it needs to evolve, right? It needs to evolve in response to not only the popularity of its products and services, means then it needs to expand, but also to penetrate other markets, or to basically um, be better than their competitors, right? So they need network. So most businesses, right now, modern businesses, basically uh, they venture into online selling, online providing your support services and products. So all these needs networks. And I said before, these networks then have to be able to scale up, right? And one of the reason why the networks, the modern networks, right, need to be adaptable in order to scale, not only in terms of the size of the network, yeah, but it also now evolve or adapt to carry different types of traffic. If you just look about 2 decades ago, you see that a different traffic carries, uh, let's say, entertainment, broadcast TV, um, carry radio entertainment, carry voice calls, right? Carry data, right? So they're all running on different networks, and they are not compatible. So in order for you to have all these facilities, you need to basically, as a business, you need to have or subscribe to all the different types of networks, right? If you want landline, you need to apply and subscribe to a landline network service, like for example, public switch telephone network, right? If you want to have streaming TV, you have to again maybe go for cable TV or over-the-air TV or even Astro, right? And if you want to have another thing that I was thinking is about the radio also on a different network, right? Wireless network, but radio, FM, AM, frequency modulation, amplitude modulation, all those, right? But as you can see, the trend is that we are moving towards this, right? And in fact, for most people, they're already using this converged network traffic. Most people consume their television or whatever media through the normal packet switching network, right? So you can see that the traditional providers like Astro also have to provide this. Even Unify have to provide this video, the Unify TV. Okay, and uh, and some of the newer providers, they actually have no other options. They just provide streaming, and they call this IPTV. Okay, because the television streaming is, or films or media, whatever, is using internet protocol. Okay, so in terms of voice calls, we now have voice over IP. Again, using the same network, which is the packet switch network, right? And all the examples that I mentioned earlier on, right, now use the same network. So what does it mean for the business? It means the business do not need to subscribe to multiple different network. Okay, so subscribe to one type of network, which is the packet switch network, and you can have all the services, okay, on the same network. This translate to easier management, and also cheaper, um, cheaper in terms of cost, okay, cost and subscription cost, right? Right. So networks also should be able to support critical application. Critical application simply means that application that is needed, okay, by that particular business. Okay, and this application, if it's not available, then their business stops. Right. So, for example, um, e- the best example is e-commerce. Okay, e-commerce, if their web application is down and is not accessible to users, then their business stops because do not have brick and mortar. They do not have any other portal except having an online presence. So these are critical application. If this kind of application is unreachable to their users, to their customers, then their business stops. Okay, basically. Now a lot of companies also do hybrid. Some has brick and mortar. Some offers sales through uh, online. Okay, but majority of their businesses actually is online. So, for example, let's take Asia. Asia, you can go to the airport to basically purchase tickets, but most people, buy their tickets online. So, if the online application is down, right? Yes, you can still buy tickets, but the number the number of sales you can make is reduced so much, right? So other critical application, you can just think about businesses and the kind of application they have and the type of services they need. So, for example, database, centralized database or distributed database. If you lose access to this, then even your if your application server is still running, but without access to the database server, then again it's disrupted. Transaction cannot be performed. Therefore, the application is paused, right? And we call it downtime, right? So these are example of critical application that the organization needs for it to run 24/7, 7 days a week, 365 days in a year. That means, if preferable, no downtime at all, because these are critical application, right? Other things are like that networks need to support it. Okay, different organization, different requirements are diverse business needs, right? Diverse business needs simply means that nowadays businesses try to not put their eggs into one basket. Okay, they want to diversify their business portfolio. So this is to counter threats from competitor, right? So and because if they solely rely on a certain business model, if a competitor beat them on it, then they don't have anything else to turn to, right? So if you diversify your portfolio, at least you can uh, you know you can strengthen many areas. Then you're not vulnerable to a particular um, you know competition type of competition. But diverse business needs mean then your requirements, okay, requirements for networks will be different as well, right? So if you, for example, want to support your point of sale, right? Point of sale, you have brick and mortar, right? You want to support your point of sales uh, transactions, right? So you might need a local area network, relatively um, high speed connection to where your data center is, your where you keep your database, but the amount of traffic required for point of sales is fixed basically, because you know you have how many branches you have, you know how many point of sales counter you have. So you basically know, okay, what's the traffic like, to support this. But you diversify. Not only you have brick and mortar, you also do e-commerce. But then for e-commerce, due to the um, flexibility of online purchasing, you can't really control. You cannot put a number, say, okay, this is my maximum number of customers. It goes up and down depending on the peak hours when your customers actually purchasing. And if you're selling globally, then you you know you don't have downtime. Okay, one side of the globe is sleeping, one side is awake, and vice versa. So uh, the requirements in terms of bandwidth required and server capability requirement and backing up and all these things are slightly larger than just operating on brick and mortar. But maybe you want to have both, okay? Because for certain region you want to have a brick and mortar presence, but certain other areas you want to have online presence as well. So different business needs require the networks to be flexible, right? Maybe uh, supporting different features, functionalities for this part of your business. Again, supporting different you know needs for another type of your business. Okay, and fourthly, centralized administrative control. So as you scale up your network, if you have a small network, I think centralized administrative control is good, but it's too much, right? If you have a small network, you actually more productive having a localized, okay, local to device administrative control, right? Because the features functionality required by small network, okay, does not justify the cost, right? Cost to provide the provisioning of this centralized administrative control. But as your business grow, your network scale up, you need larger networks can support more hosts, right? And can connect remotely to other parts of your network, to other business areas. So it becomes very difficult, and sometimes it will reach to be unmanageable if you do uh, configuration for the control of your network devices individually. So it's much better to now consider to have centralized admin control. That means in one central location, right, you can control triple A configuration, or authentication, or authorization, all this over all of your devices all over your local and wide area network. Okay, centralized administrative control. Okay, all right. So one example we can look at is campus network design. So what better example than to look at our own campus, right? So our own campus, all the administrative control is actually centralized in KL. A lot of the um, even the bandwidth throttling, the firewall, we are using a cloud-based firewall with its own blacklist and whitelist, right? But it's all controlled centrally, okay, by a CITC in KL. So this is an example of this what we talk about here, centralized administrative control. But different businesses also is there because if we compare a larger campus like a main campus compared to Sabah campus or Pahang campus, we are small. The network needs simpler, yeah, simpler. So because, for example, our student population perhaps reach 300. So that means at any one time, if they're using network, you have about 3 to 400 users. But in the main campus, in order to support, they have thousands of combined, yeah, the main campus have thousands of students, all probably needing network services. So the kind of infrastructure, the kind of you know networks facilities that they need is different. So you can see here diverse business needs, right, in terms of campus network designs. And that we do have critical application as well. Critical application here, we can include the internet that you guys, your students have to go in, staff also have to go in here to regularly maintain certain information, right, or to view certain information. So these are critical applications, right, dealing. And converged network traffic, we now do video conferencing due to doing online, okay, online teaching. We have video conferencing or voice calls, all using converged network. That means a single packet switch network helps us to transfer our videos, right? Consume our for teaching or learning purpose. Maybe we go to YouTube, right? So these are streaming videos, streaming media, all using same network, converged network, right? So campus network design includes small networks that use single LAN switch. Yes, we do have this in Sabah because we are quite small. Uh, for example, each um, each of those labs network probably is connected to a single switch, and this switch, the Cisco or larger switch with maybe perhaps go to up to uh, 24 or 48 ports each. Yeah, right. So in that design, we do have a small network design. But then again, as I mentioned earlier on, if we go to the main campus where they have thousands of students, so then the network will be a very large network with thousands of connections, right? That means you need to plan differently for the larger networks, right? So let's talk about this concept of Cisco borderless network. It is a network architecture, right? That Cisco is promoting, yeah. And it says this is basically part of their what slogan. It says that Cisco Borderless Network is a network architecture that can connect anyone, anywhere, anytime, on any device securely, reliably, and seamlessly. Right? Seamlessly means the user is not even aware what's happening. They just know they can use the network, right? It just work. That's it. For the user point of view, the network just work seamlessly. I can go from one location to another location because the campus is so big, right? I could be walking about. 200, 300 meters away. So the thing is, of course, um, our range of Wi-Fi, let's say Wi-Fi, okay, Wi-Fi is about 100 meter. So let's say you walk about 300 meter. So definitely you are going to go out of range of the Wi-Fi access point, right? But you will get into range of a different wireless access point. Seamlessly means as you move from one coverage of a Wi-Fi coverage into another Wi-Fi coverage, you don't even realize that you're being passed over, right? So the other access point is passing you, okay, as the client to another access point, and to you there is no difference. You still connected to the network, okay. You don't even realize that you've been passed between one access point to another access point, right? So it works seamlessly, right? So this is what most networks, uh, you know, are designed to provide functionality that works seamlessly. Okay, not aware. You don't have to disconnect first. Oh, I'm going out of range of this access point, so I'm gonna disconnect from this access point, and then I'm going to enter another access point range. Then I'm gonna reconnect for to that one, right? So that is not seamless. That is you are aware that of the design of the network, that, and you have to physically or manually change configuration in order to make use of the services, right? That is not seamless. Seamless means you're not even aware that you are leaving one access point and entering another one. Okay, the range, yeah. Okay, it switches seamlessly, and the provision of the network is transparent to you. You're not even aware to configure. All the IP address is given through dynamic host configuration protocol, so it's even automatic. You don't even have to think about what address can I use, right? Okay, so this kind of borderless network, right, can provide that. It provides framework to basically combine wired and wireless access. Okay, and this network is built on a hierarchical infrastructure of hardware, and which is scalable and resilient. Resilient here means this network is, yes, bad things can happen to the network. Some parts of the network will go down, but it will not simply uh, the whole network just simply go down, all of it. That means you can't access anything at all. Resilient means resistance to this kind of problem, right? So if there is a failure, it will be a graduated failure. It's you will still have access to the functionality features of the network or services, but maybe at a lower speed, right? At a lower speed, or you know, a reduce in the full functionality or full speed, but you will not lose total access to the network. So this means resilient. Scalable means, okay, let's say Taoist is so good. This year, additional 5,000 students join Star UC. So we need to provide network access to those students. Uh, is the current network scalable that we can just simply fine tune it, add certain things in order for it to seamlessly be able to support the extra 5,000 students? Okay, that's the scalability. Okay, right. So borderless switch networks are hierarchical because you can see there is a hierarchy, right? Hierarchy means there is one level, and then above that another level, above that another level. So there is a hierarchy. Each level signify different features or functionality. Okay, it's modular means you can add, you can remove. Okay, and then that means you will be able to change the topology without much difficulty, right? You need to add another LAN, just simply add the LAN in and just snap in, right? It works. It's modular, right? Think of Lego. You play with Legos before. you if you want to add to whatever you're designing, you just take a piece and plug in, and it becomes larger. So it's modular. And if you don't want, then you can just simply plug out, right? And then your networks reduce, or the topology is changed, right? So again, resilient here that we talked about earlier, right? Flexible, right? It's flexible. It's able to accommodate up and down the number of users, right? Without and the provision of additional bandwidth if needed, right? And to provision of the resilient here, basically redundancy. Okay. Okay. So here is an example where you can compare. On the left is a three-tier layer network, and then the other side, the right hand side is a two-tier layer network. All right. So what's the difference? Okay, this is a time when you can. Have you guys played with the, you know, uh, you're given two photos, two images, and then you have to find out. Okay, in one image, what's not the same, and you tick, and you can find a few. So here you can play that also. You look at the two images and see what's the difference between three-tier and two-tier layer. What is missing for the two-tier? Well, very easy. So you can see here the labels. Access layer are the one closest to connect or to provide network services to hosts. That is the access layer, how the user access into the network. So at the three-tier layer and the two-tier layer, both has access layer, right? Both has access layer. Then the next is the distribution layer. Distribution layer basically connects all the LANs together. And you can see, right? These are multi-layer switch or switches, right? They act as a switch, but at the same time, they also act as a router. Okay, that's why we call it a multi-layer switch, right? And then eventually we'll reach the core layer. Okay, the core layer before we go to the edge router. Core layer provide um, larger bandwidth. Also, you can see here ether channel being created. Recall that we've learned about ether channel. So ether channel is a way to combine multiple links between two switches or two multi-layer switches um, to form a higher bandwidth, because now all those links we combine together into to form a single logical link. Okay, and we can aggregate each of the links speed. Okay, so they total up. So let's say uh, you can see here we have four links. So let's say each of them is a fast internet link of 100 megabits per second. So if you have four links and you combine them together into a single logical link, that means we just simply multiply four, which is four links, multiplied by the speed of each link, which is 100 megabits per second. Therefore, between these two multi-layer switch, you have a 400 megabits per second logical link. So this what is the ether channel, recall, and you can see the way it's cable up. Okay, we actually allow redundancy because we are able to create multiple paths. So you can see from this multi-layer switch, it can reach this multi-layer switch, but it also have a way to reach this multi-layer switch. So that means in order to reach the internet, right? You can see these are double up. Okay, so you can even imagine the HSRP here, the gateway virtual router can be actually should be installed in these two routers, right? So to reach the internet, these are not two separate instance of internet. This actually there's only one internet, but just we want to say that to to access the internet, we have two in from this three-layer architecture. We have multiple ways to reach into the internet. In terms from the topology, we can see that there are one, two, three, four, four access into the internet. Okay, this is providing redundancy. So we try to minimize downtime for the business because downtime is actually very costly. Okay, especially if your business rely on networks. Okay, provisioning of networks. So here we can see the resilient thing happening. Recall back. Let's go back here. You see that we want this hierarchical. Hierarchical. You can see layers: access, distribution, core, right? So because the function is different, so distribution layer basically distribute the bandwidth between and to connect all the switches together. Access layer is to provide uh, access for the host into the network, and then core layer usually provide higher bandwidth speed to connect multiple LANs or down here and to distribute the access layer, and also to connect to the become form a backbone of your network. This is your backbone of network, meaning just like your human backbone, you connect your processor, which is your brain, to all your limbs, your body, where you want to control, or it's a two-way street, right? You want to provide control. The electrical signal from your brain goes through your backbone, the nerve running along your backbone to everywhere in your body, so you can control any parts of your body. But at the same time, from your sensors, pain sensors or whatever receptors you have, it also sends signal back to your brain via that uh, that main nerve, okay, running alongside your backbone. So for the network, a backbone simply means it carries to and from, okay, any parts of your network, very high speed, right? At very high speed. So it's very important that you if you don't have this backbone, high speed backbone, if you cut it, then some parts of your network won't be able to reach the other parts. Okay, they might be able to reach via the internet. Okay, but then you have to employ virtual private network to ensure security, right? But the trusted mode is inside your own network, right? And high speed because it's LAN, right? So yeah, core layer is very important. Okay, so when you look at the tier three tier, tier layer, you have to look at these features: hierarchical, modular, resilient, and flexible. We see the resiliency because of the redundancy, the duplication of devices, okay, and also the provisioning of alternate path, okay, so that you can reach uh, the internet and each of the hosts or each of the devices, intermediate devices, easily, even if one path perhaps go down or faulty. And it's flexible. You can see modular and flexibility simply by looking at every layer you can add in or remove. Here, access layer, where is it? You want to add more wireless capability, access to your network. Provide this wireless controller, right? More wireless controller. Just simply add and plug into your switches. You want to create more LANs, provide more switches. Or alternatively, if your switch supports it, create VLANs, right? So that is flexible, that's resilient. Scaling up, you can scale, right? Similarly with distribution, you can see that you can just simply add more multi-layer switch for the ether channel. You can simply add more links for the routers you that can do load balancing, as a gateway router, right? You can add more routers. Okay, so this basically this combine all what we have learned throughout the semester. Okay, we look at virtual LANs, we look at interrouting between virtual LANs, we look at ether channel, we look at trunk links, yeah, we look at HSRP, then we look at the ERGRP and OSPF. ERGRP, we learned earlier, OSPF is a way for the routers to distribute their remote networks information in their routing table, right? So the difference between three-tier layer and two-tier layer, if you notice already, is the core layer and distribution layer is combined, right? So I will imagine that three-tier layer is for a larger network because you can see we need a high speed, okay, high speed connectivity at that layer. Okay, you can see by this combined link to for forming interchannel. Okay, so if you don't have this need, okay, this need, then you can combine the core and the distribution layers together, right? Okay, you still have access layer, but now core and distribution layer is combined. And so we know that two-tier layer is actually meant for smaller network, not too small because this is still considered a large network, but not as large as the three-tier layer where you need uh, communication between different parts of your network to each other. Okay, but via a high-speed connection. Right. So here are the explanation on each of the layer. Access layer basically provide access to for the user to the network, right? And access layer switch connects to the distribution layer switches, which is just above it, the layer above it. Okay, above access. Okay, is distribution, and then distribution layer implements routing as a multi-layer switch. Yeah, can implement routing to enable traffic from different LAN or different VLAN, okay, to be able to forward, yeah, from one VLAN to another VLAN or from one LAN to another LAN. Okay, implement routing. Uh, is concerned about quality of service and security. Okay, so distribution layer aggregates combine, yeah, large scale wiring closed networks and limit layer 2 broadcast domains. We remember this in chapter 1, limiting layer 2 broadcast domain, because broadcast domains is very common, okay, in layer 2. It's used by ARP, it's used by a lot of other services. So by segmenting your network so that you can limit broadcast domain means you can prevent congestion due to the broadcast. Okay. The only on the so how do you segment broadcast domains is by using layer 3 device, a router. In this case, multi-layer switch. Okay, multi-layer switch. Right. So distribution layer usually use a lot of multi-layer switch rather than routers. Yeah. Okay. So distribution layer connects access layer to the core layer, right? And as I mentioned before, the core layer is the network backbone. Yeah? Like the backbone of a human being backbone, right? Carry the human being backbone protects our nerve, yeah, our main nerve to carry electrical signal, right? So the same network backbone is a high speed, like a highway, where all the network traffic can from one part of your network can reach another part of your network. This is before reaching the internet itself. Okay, that's a different area lah, the internet that you want to access. All right. Okay. The core layer provides fault isolation. That means if there's a fault at one part of your network, then it will be isolated there because you can see from the previous three layer architecture or hierarchical network, right? You simply can segregate, okay, one part of your network and the other part of the network by the two multi-layer switch with the interchannel, right? We can actually isolate the problems, right, very easily. Okay, right. So coming back to our campus network as an example, you can think about how you see campus. Okay, if you want to compare, right? So for a campus level, is three tier. You can see that it's a larger network. Here we can see the topology. Yeah? We have building A, building B, C, D, E, F. So this is a large campus, and this is like what we have in main campus. Okay, you have a different building. Um, even for FOCS, we also have many different building. Okay, the building where all the lectures are held. They also have a different building for all the labs, right? So you have to physically walk. Okay, there's a distance, yeah, between one building to another building. So in terms of network, if your network at that particular building and then you have another network for another particular building, then they are basically not part of each other's network. So each building will have its own LAN or LANs. Okay, right? So access would be individually at the lower level where the host connects to the network. So it makes sense. If your building B has LAN, we call marketing and sales. Building C have engineering LAN, and so on and so on. Then the access layer should be situated at each of the LAN at the building, right? Then to connect building to another building, that means each building may have one or more LANs. Then we want to connect them. So then we at the distribution layer, right? At the distribution layer, we have multi-layer switch. Okay, and then all this will be connected to a single location, shown here as building A, which is part of management LAN, and we can consider that part as the core layer, right? So why we need high bandwidth at the core layer? Because we basically aggregate all the network traffic from all over the place. Traffic from building A, traffic from building C, F, E, and D all congregate here. Okay, that's a lot of traffic. So that means at this layer, you need to provision high bandwidth. Okay, at the core layer. Okay, because all the traffic congregate here, converge here. All right. So if you have a campus network that you want to design as a three tier, right? So that means you want all three access, distribution, and core layers. Then you can create a physical extended star network, right? And you can run it out from the centralized building location, connecting to other buildings. Each building perhaps have one or more LANs, right? Now, two-tier campus network is for smaller campus, right? We have maybe a single building, and how we divide the building is by floors, right? And so different floor has a different functionality, business functionality. So, for example, you can see on the screen here, right? We have second floor belong to management, third floor belong to IT, fourth floor belong to server farm, five is engineering, six is R&D, research and development. So we can consider in this way. Each floor should be a LAN, okay? And all these floors, all these LANs or local area networks are connected to a single distribution slash core. It's a collapse. Collapse means we combine both core and distribution layer together because we don't have a need. You can see there, we don't have a need. So this floor six floor, maybe this is actually belong to a building. Okay, so this is just one building perhaps. So if we have multiple building, then it makes sense to have distribution and also core separated. But here we only have one building. So if you only have one building, then it's not necessary to have two separated layers like distribution and core. So we combine those two. Okay. So it's for smaller campus. Campus size consisting of a single building. That means your lands are smaller, close to each other, right? And that means separate distribution and core layers are not required. We also know this as collapsed core network design. Okay, it's another word for it in literature. All right, so let's have a look at the role of switch network. So we are transitioning from the previous topic to scalable networks. So we have a look at the three tier. Okay, we see that here are the hosts. Then here are the routers, and below the routers we have multi-layer switch, and then under multi-layer switch we have all the switches, right? So you can see that switch and multi-layer switch plays a very important role in our network, right? So it's a way for us to connect hosts together to form a LAN. It's a way for us to scale our LAN by having an extended star topology. And with the higher functionality switch, that means multi-layer means it can go up to layer 3, right? It can even separate different LANs, okay? Different LANs. So because it's basically acting as a router, okay? So you can see at the distribution layer, right? So conclusion, multi-layer switch can exist at the core layer and distribution layer, whereas router exists on the core layer. And for access, normal switches with hosts, right? Okay. So this is basically an improvement from the old network where it uses hubs. Hubs, you can if you can see a lot of hubs here, you can basically say the broadcast domain is heavily congested, right? And also the pollution domain also heavily very bad. Okay, so the moment we swap out hubs with switches, we improve our network. We can with multi-layer switch, we can actually segment broadcast domain. With switches, we can then segment um, the collision domain, right? By virtue of the switch is full duplex. Okay, hub half duplex. Okay, you know that hub as a hub half duplex cannot have simultaneous transmit and receive at the same time. Okay, that's why it's called half duplex. For full duplex, you can have to be receiving and sending traffic at the same time, right? So there was a big improvement after introducing switches to replace hubs. Yeah. So a switch line also provide flexibility, traffic management, quality of service, and security, right? And switch LAN can also, if you connect an access point to the switch, also can support wireless networking, all right? Also support VoIP or voice over internet protocol, IP telephone, we call it sometimes, right? And mobility services. All right. Okay, so we finished one section, right? So I'm just gonna ask you guys for feedback. Any questions so far on the topic just now?
So far, no question.
Kevin, okay, so no, Kevin, no. How about Noel? Any comments?
No.
Anything to say or ask? Clara?
No. No question from me.
No question. With me. All right, no question from Farah and Noel. All right, thank you for your feedback. welcome back. Let's continue with scalable network. Okay, we talked about scalability just now. So we want to design for scalability means we want to design our network so that it can grow. Okay, it can grow means it can you can add more switches. Okay, that means the star network topology become extended star, right? So basically, why do you want to grow it? Because requirements from business. As you expand your business, you got more employees, right? You open more branches, you need more hosts, and all these hosts needs to connect to the network, right? So scalability here simply means you might, when you look at the three tiers now, you look at the access layer, there are more hosts. That means you have to then provide more switch. Then when the current distribution layer is insufficient to support the new hosts and switches at the access layer, then you start to grow, you can start to scale up your distribution layer. Again, you wait until right. So if the core now is unable to support distribution layer because it's increasing, yeah, then you basically scale up your core, right? Your core layer. Right, scalability means a network can grow without losing availability and reliability. That means if your network grow, yes, you can add things in, right? But in terms of the bandwidth, you must maintain the bandwidth. The bandwidth is basically the amount of data that you can transfer within a specific period of time. So you don't want the bandwidth suddenly go down because you keep adding hosts. But then you don't consider all these hosts will take up bandwidth. So you need also to provide enough bandwidth if you are scaling up the number of hosts, right? Then um, more hosts means more connections to the switch. More switches means larger networks normally will increase the probability of network failure. All right. So this is where we talk about availability and reliability. Okay, let's distinguish between these two. What do we mean by availability? What do we mean by reliability? Availability here means downtime. Okay, it's measuring the downtime. So if possible, we don't want any downtime. So it's available all the times. The network is available all the times because there's no downtime, right? Even if there's downtime, we want the downtime to be as short as possible. Reliability means how often does it happen, right? If it happens all the time, that means your network is not that reliable. Okay, it seldom happen or never at all, then it's very reliable, right? You can rely on the network to work, right? So how do we provision for this availability and reliability? That means you have to develop strategies that make sure that or ensure that network will be available all the time, but still allow you to scale it up. Okay, and you can scale it up easily. Okay, so the things that you have to consider are redundancy. You want to introduce redundancy. Okay, introducing redundancy means you will have a duplicate. Okay, no choice. You have to duplicate. Just like NASA, they like to everything they design on the spacecraft, they do double. Okay, at least the minimum they have two of everything, because especially in space, if something gone damaged, okay, you can't simply say, oh, I need another one, right? So it's good to have a duplicate. Okay, if something gone wrong with the first one, there's at least another copy that works exactly the same way that can take over, right? Can take over. So that's redundancy. So in network, if you want to avoid network downtime, means it can even if there's something wrong, it must continue running, right? So the only way to do that is to provide redundancy. Redundant in terms of the switch, okay? The switch and the path, the switch and the media, okay? That means providing alternate path. Example, you want to come to college, how many paths can you drive through? Maybe you have like 3 ways to come here. So path one is traffic jam, make you late to go to the exam, for example. So now, rather than miss the exam altogether, you consider the other two paths. So you take alternate path and you can still arrive here. This this is the concept, right? For redundancy in the network. Okay. If we accept there's going to be a fault, okay, we cannot prevent totally, but we make provision. If there's a fault, then there are other parts of the network that will take over the job. Okay, so that we minimize the downtime. Means we provide multiple links, multiple paths. Okay, like a different road path for you to come over to campus. Okay, just in case one or two is traffic jam. Okay, you want to still arrive here on time, you take another path, right? Thirdly, scalable routing protocol. So that means the routing protocol is the is the way for the routers, okay, to forward packets. So we've seen ERGRP and OSPF. Okay, it's a way for the routers to exchange routing table. Remember, routers use routing table to make routing decision, right? But each router only knows its directly connected network. It does not know any of the one hop away or remote networks. So each of the router will inform each other. Okay, hi, I'm router A. I have this info. I'm going to send to you. You don't have this info, right? So hopefully, if I give you this routing table, whenever you receive a packet that you don't know, okay, about because you only know certain directly connected networks, then using this piece of info I give to you, then you might be able to forward that packet. All right. So scalable routing protocol means you have to look at the routing protocol that you have decided to use for your router to see whether it is scalable. What does it mean by scalable? Means if I add new routers and this router is part of the administrative, okay, the AS, right? I can just simply add the router in and my routers will without impacting too much on the bandwidth, they can still exchange information. So this is scalable. I can grow the number of routers I need as I need them, right? And another one is to expand the network is to provide wireless connectivity, right? Is the easiest way to provide access to your network without much cost. Why? Because there's no wiring. There's no wiring needed, right? For wired network, every time you want to add host or a LAN, that means you have to physically design the physical topology and do your wiring, your cabling, right? Okay, and it's not sometimes not that easy, especially if it's not a new building, right? The wiring to consider, but the easiest way to expand your network without wiring, without spending, you know, a budget on preparing for the wired LAN, then it's wireless. All you need to do is basically provide the access point. Okay, this access point will accept connection from your wireless client, and suddenly you have a wireless LAN. Okay, that means you already expanded your network. Okay, so planning for redundancy. Okay, I want you to look at the diagram here. You can see the highlighted path in yellow. Okay, those are redundant path because from S1 to S2 to S3, you can see a direct path, isn't it? And then from S2 to S8, direct path, and then to server. Okay, S5 to S6 to S7 to S4 to that server to that server to that server, right? So that is the normal path. But let's say I want to provide redundancy. Okay, if I cut here, then S1 to S2 without this in the middle, this link in the middle, then S1 and S2 is isolated. S1 cannot connect already. But look at the look at the way I cable it. From S1 I connect S6, S6 I connect S3, and so on. Then we suddenly see this is not connected. This one is not connected. This is actually overlap only. Yeah, overlap. So basically S5 connected to S2, S1 connected to S6. So how many paths? For S1 is two paths, right? If this path is is disconnected or this switch is down, this I can still S1 can still take this S6 path, right? And then from S6 I got two paths, and then from S7 I got one path to S4, right? So you can see this is one of the design, the crisscross design I call it, yeah, to basically provide redundancy so that you can mitigate if any of the device or any path is disconnected, then you have an alternate way. That means there's no downtime, it still can continue, your network still continue running. So no choice, you have to budget to install duplicate equipment, right? This is the term here just now, redundancy, providing duplicate equipment, exactly the same equipment. Okay, so if you're a small company, of course, it seems very costly. I already have a switch. Why I want to buy another switch? Okay, so you have to balance between your absolute need for no downtime without and your budget, actually, right? Secondly, providing failover services for critical devices. It means if critical device go down, then what other service you can have? So I mentioned earlier on last time when we go to Sabah Credit, okay? So they were showing us their internet connectivity, okay? So I can tell you that they do have this failover services for critical device because it's their server, it's their system connect to the internet maybe for remote, okay, remote connection. Okay, of course they use VPN, I guess, right? So their main is the fiber optic connection. The secondary connection, okay, if the fiber optic not working, they have the ADSL, okay. I'm not sure ADSL or SDN. ISDN is a cheaper alternative, right? Or older alternative as well. Then finally, they have satellite connection. So if all else fails, notice that each of these are running on different technology. So if the fiber optic technology is not working, then they can go to public switch telephone network using ADSL too. And if that is not working, they can rely on satellite, which is again a different medium. Okay, so this is how you want to provide failover services. You sometimes you want to, because these services are not equipment. Equipment, yes, you can buy the same model switch. But then you have two of the same switch, right? But for services, to prevent, because if the service for this particular service, the internet is failed, if you have a second also coming from that kind of service, because there's the same services, they both maybe not working. So if you want to provide failover services, consider using different technology. So fiber optic, public switch telephone network, satellite. There are three different technology, so that the chances of all three different technology is failing is very low, right? Very low. So you're safe to consider. Okay, I will never lose internet connectivity because I got all these three. Yeah, performance may be great because satellite maybe is too it's slow compared to fiber. Yes, ADSL2 may be slow compared to fiber, but at least you're still connected, right? Connected, maybe at a degraded service, right? Then we have to consider redundant path. Redundant path, I'll talk about this one, alternate path. Okay. Now, please remember, in layer 2, redundant path can cause loops. Loops is bad. Loops will cascade to broadcast storm, and this broadcast storm can bring down your entire network within seconds. So always, if you want to provide redundant path in layer 2 to avoid this logical loop is to use STP, or spanning tree protocol. Okay, so therefore you have to purchase the switch that supports STP if you want to use that switch as part of redundant path. Okay, if you go and buy, I want to have redundant, and then you buy the cheaper switch without STP, then you find cannot work because of the broadcast storm. Right, so you have to consider this. Yeah, I want to provide redundant path, then I have to consider STP. Means I have to buy a switch that provides STP service, or STP as a solution for logical loop. Okay. Reduce failure domain size. All right. So well-designed network controls traffic and limits the size of failure domains, the area of the network that will be impacted if there is a problem. Okay, it is a problem. In the hierarchical design model, failure domains are terminated at the distribution layer. So if you look at the distribution layer, you can see the multi-layer is connecting other switch. So if this particular switch, if this is producing a problem, simply disconnecting that part, you can then stop any problems from propagating to your entire network. Right? So every route, just remember that distribution layer is a multi-layer switch. So every router functions as a gateway for a limited number of access layer users. So it also segments your broadcast domain, at the distribution layer, because at that layer the switch is a multi-layer switch. So it means it can act as a router. Right? So routers or multi-layer switch are usually deployed in pairs in a configuration referred to as a building or departmental switch block. Each switch block acts independently of the others. As a result, the failure of a single device does not cause the network to go down. So basically providing redundancy. Right, so the next one is the provision of higher bandwidth using Ether channel, isn't it? Because between your intermediate device like switch and multi-layer switch, because the switch aggregates all the bandwidth from all the hosts, and then they're going to share this link, right? This link. So this link has to be faster because it's a combination of this 100, 500 already, right? So you want to achieve at least 500 megabits per second. So you combine links, right? So that they and aggregate them become a single logical link, like Ether channel. Okay. Now Ether channel also can do load balancing, meaning to say, if this link here as part of the Ether channel is saturated, then it can choose to use the other link as part of the Ether channel to lessen the burden of the other link. So it's load balancing. Okay. Right, expanding access layer. Okay, one of the increasing popular option, as I mentioned before, to scale up your network accessibility is to provide wireless access, wireless network, and it's very easy. Connect your access point, and that access point can create another wireless LAN for you. Okay, but for this, you need to consider when you want to implement wireless network, what are the type of wireless network connecting to your wireless LAN? So what kind of protocols do you support? I think right now it's up to AC. Okay, I think the next one is not yet here. So, but the thing is, no point you put AC, but all the bring your own device. Okay, all the device your client has are all not supporting that latest bandwidth. But for future, maybe scalability for future. Okay, you're thinking of in the future they might change their, you know, upgrade their devices. Maybe for that reason, yes, you can basically purchase access point that supports more recent protocol. What is your wireless coverage requirement? So again, 5 gigahertz between 2.4 gigahertz. 2.4 gigahertz they have longer distance to support. Okay, but at a lower speed. 5 gigahertz has shorter distance support, but at a higher bandwidth, right? Then you think about interference consideration, right? Before you purchase your or install your access point, do a quick scan on the surrounding area. Okay, check whether what other access point is operating. It may not belong to you. At what frequency, okay, and at what channel. So that when you configure, you try to avoid the same channel, you try to avoid the same frequency. But you can have the same frequency as long as there's an available channel, then you can switch over to that channel so that you have the channel to yourself, so it doesn't clash with the other access point, right? And then you consider security. Security, either using the WPA tool security where you use authentication, right? Or you use a different radius kind of security configuration, right? Is it going to be open where you don't consider any security threat, so you just have an open Wi-Fi, something like that? So these are the security consideration that you have to consider when you're implementing a wireless network. Right, tuning routing protocol. So routing protocols, there are two that we have looked at. In computer networks, you look at EIGRP, right? And then in this semester, you look at Open Shortest Path First, or SPF. Okay, and it works basically same as EIGRP. It's basically exchange routing table info and create adjacency with the other neighbor router. Okay, so if there is any network change or topology change, then the link state updates will be sent, informing other OSPF routers of the change, and they will establish a new best path. So SPF has a way to judge a path suitability or the cost of a path. So OSPF basically, okay, not only sharing the content of its routing table, but also work together with other OSPF routers to find out what is the best path. That means because the routing table is the one that's going to inform the router where to forward the packet. Where to forward the packet as a whole, all the routers work together. What is the best path from this router if for the packet to go to a particular network? Right? So that is the optimization of the path, the routing. Okay. All right. Okay, so I think we finished here. It's at 3 o'clock already, session done. So we've done a couple of topics, right? The other two topics are switch hardware and router hardware. So we're gonna continue that in our next lecture. Basically, for switch hardware and router hardware, you can read ahead. It talks about all the different types of models for Cisco switches and routers and their suitability in what kind of network, large, small network. Okay, we'll have a very brief look at it before we start our next topic in the next lecture. All right. So for now, okay, let's have a break. Oh, Noel. Yes, I'm not in the lab. I'm doing I'm doing this lecture from my office room. Yeah, so I didn't know that you were online. I mean, came here to campus, or else I will. Okay, never mind. We can do it at the lab. But tomorrow I will be in. I will be at the lab. Okay, so please let me know if Noel, Trevor, or Kelvin, you are in campus. We can do the practical. Although I cannot promise you the hardware, but we can do the practical in our Cisco lab tomorrow. Let me know. Let me know before so I can get ready. Okay, but tomorrow I'll be in campus, so if you want, I can be in the lab, so you can also get into the lab. So okay, Noel. All right. Okay, so let's take a quick break before we go for tutorial. Let's say now it's 3:04. Let's have a 10 minutes break. So 3:14. Okay, 3:14. We resume. Okay, the tutorial. Also, let's join the tutorial meet. Yeah, tutorial meet. Noel, you have three more. Syslog server is correct, but you have three more. Okay, this one is correct. You have three more destination, three other destination. Maybe you can try find out which three. For Kelvin, do you remember the magic number I was talking about? Magic number because we need to know that number to actually perform the reset. Okay, Kelvin.
Oh, I forgot about it. Is it the two? Is it that the the D?
Are you there, Kelvin? For question number 6.
Yeah. Is it the D? I forgot about the magic number.
Right, syslog for Noel, console line, yes, that's one of it. Syslog server, yes. Terminal line, yes. Logging buffer, which is RAM. Okay. Okay. So now the last question. The rest all okay. CDP run, layer 2 for question 2, NTP server for question 3, three components of SNMP, manager agents and MIB, correct? For Kelvin, okay, you do you remember that you have to type that number? Okay, 2142 is the magic number, right? So you have to type config, okay, 0x, yeah, 2142 at Roman 1. Okay, check out the slide to see. And you have a different magic number when you need to reset back after you remove the password or reset the password to go back to secure mode. So you have to another number. Okay. This is the first number to get into the to be able to change the password, right? Then another number later. Right. So G is correct. Okay, I config 2142 in hex at the Roman 1. All right, so that's the tutorial. This one is quite brief, it's easy to do, right? For the next tutorial, tutorial 11, I will share as we cover more of the chapter for tutorial 11 in next week. Okay.